Hi everyone, so now we will look at the question 2. Okay, so the first question is to find the volume under the surface. Okay, so the equation of the surface is this one. It has been given in the questions. Okay, so since the surface has been given and over the rectangle R, the region also given, okay, you can choose not to draw this surface also. And in fact, this surface is actually quite difficult to draw. Okay, if you're interested, you can use the GeoGebra to have a look at this surface. So this question is only interested, okay, on the volume, okay, that is in between the region 1 to 3 for the x, 0 to 2 for the y, and this region is under the surface. Okay, so you can just use the formulas for the volume. Okay, so we can look at the question 2a. Okay, question 2a. So you have your z. So this is the surface, which is equals to 3x squared plus 3x squared y. Okay, and the y is in between. Okay, the y is in between 0 to 2, and the x is in between 1 to 3. Okay, so to find the volume, okay, you can use the double integral to find the volume. So the formulas for the volume will be double integral. Okay, then you will have a f, then you will have a dA. Okay, so this f, okay, stands for the functions of the surface. Okay, function of the surface. In this case, the f will be the z, okay, which is 3x squared plus no, it's not x squared, x cube, cube, okay, and 3x squared y. Okay, so the dA will be based on the projections. Okay, will be based on the projections. Okay, so in this case, the projection range has been given, which is from 0 to 2 for the y and from 1 to 3 for the x. Okay, so you just need to put all the info inside. Okay, so you can put the range for the x, then the range for the y, and then you put the f, okay, plus 3x squared y, and this is dy dx. Okay, dy dx. Okay, so here you can do the integration manually. You can do the integration manually. Okay, 1 to 3, and this will become 3x cubed y, and plus 3x squared y squared over 2. 2 and 0 are dx. Okay, so you can replace the value of the y with 2 and 0. So here you get 3x cubed, this is 2, okay, plus 3x squared, so it will be 4 over 2, okay, and dx. Okay, then you will have a 6x cubed plus 6x squared and dx. Okay, so you can press calculator for the answer. So this one you can press calculator for the answer. So the answer will be 172. 172 unit cube. Okay, because this is the volume. Okay, so this is for the first questions. Okay, we go to the second questions. Find the surface area. Okay, find the surface area of the portion of the paraboloid given by the equation that is above the xy plane. Okay, so the keyword is the surface area. Okay, surface area. So this is answer. I highlight it. Okay. Question 2b. Okay, so it's a surface area. Okay, you can refer to the formula sheet. What is the equation for the surface area? Okay, so this one will be the equations. So you have the del z del x square plus the del z del y square and plus 1. Okay, so I select this equation because it's based on the xy projections. Okay, so this equation is valid just for the xy projections. Okay, xy projections. Okay, I will choose the xy projection because it is a paraboloid, right? So if you pick the xy projection, you are very sure that it will be a circle shape. Okay, so the question telling us that you have a paraboloid, okay, and the equation is z equals to 1 minus x squared minus y squared. Okay, so this is your equations. Okay, this is your equations. Right, so the first things that you have to do is, okay, you have to find the del z del s and also the del z del y. Okay, because you need to form the formula. So the del z del x, okay, would be negative 2x. Del z del y, okay, would be negative 2y. Okay, so when you square it, okay, when you square it, it will become, okay, you have to square the negative also, 4x squared. Okay, and this one will become 4y squared, right? Okay, so now you can put it inside your formula for the surface area. Okay, you integrate, so it will be straight away replace it. So 4x squared plus 4y squared plus 1. Okay, and dA. Okay, and dA. Okay, so when it comes to dA, okay, you have to choose projections. Okay, so just now I already explained I want to choose the xy projections. So how does the paraboloid looks like when it is the xy projections? Okay, so the paraboloid maybe the shape is something like this. Okay, just roughly sketch the 3D, the paraboloid. Okay, so this is the paraboloid. Okay, so when you go for the xy projections, so you will see this circle, right? So this circle happen at the position where the z is equals to 0. Okay, so when you want to define the dA, okay, you need to firstly identify the shape. Okay, so this is a circular shape. So the dA over here, I think you would choose the polar coordinate, right? Polar coordinate. So which means that you need to find the dr and also the d theta. Okay, so dr depends on the radius of the circle. So this circle, okay, the radius you could get it, okay, by using the formula of the paraboloid. So this is the formula of the paraboloid. Right. Okay, so when it is 0, okay, the z is 0, okay, you will have a circle that has the radius of 1. Okay, 1. So meaning that your dr, okay, will be from 0 to 1, and your d theta will be from 0 to 2 pi. Okay, so you can put it inside, okay, for your surface area. So surface area will be, okay, 0 to 2 pi, 0 to 1, and just now we have this 4x squared plus 4y squared, right? So I make it to be this way, okay, because later on you need to convert into the polar coordinate, right? Okay, so this one you could convert it into the r square. You could convert it into the r square. Okay, so you can use the calculator. Let's try to use the calculator to solve it. So you have integrate square root 4r square plus 1. Then behind outside you have one more r, right? So 1 0. Okay, so you could get your answer, which is equals to 0.85. Okay, d theta is here, 0.85. Okay, 0.85. And then for this part, it will be times 2 pi, right? So you get 5.33, okay, unit square. Okay, so this one will be the surface area. Okay, next questions, go to questions 2C. So an ellipsoid is given by the equations, this one. So this is an ellipsoid. Okay, ellipsoid means that the shape is something like sphere, but the sphere is a round shape, right? So the ellipsoid is in the ellipse shape. Okay, sketch a three-dimensional graph for an ellipsoid and its projections on a suitable plane. Okay, so you can sketch this thing. Okay, and next one is to find the volume of the ellipsoid using triple integral by changing it to the cylindrical coordinate system. Okay, so you have to sketch and then you have to find the volume. Okay, so we go to the sketching. So this is questions 2C. Okay, so how to sketch the ellipsoid? First of all, let us draw the write down the equations. So this is the ellipsoid. If you want to know the intersection point of this ellipsoid, right? So you have to look at the right side. Make sure the right side is 1. Okay, if you want to make sure the right side to be 1, you have to divide 16. Okay, derive 16 here. So it will become x squared over 4 plus x squared over 4 and plus z squared over 16 and equals to 1. Okay, so this one, okay, you can start to you have your drawing. Okay, when the x value is 4, okay, it means that the intersection point at the axis x would be 2. It's not 4, it will be 2. Okay, it will be 2. Or maybe the general formula, I should write it. Okay, oops, this one is wrong. This one should be y, right? Okay, the general formulas for the ellipsoid, it will be x squared over a squared plus the y squared over b squared and plus the z squared over c squared equals to 1. Okay, so the A, B, C will represent the intersection point at the axis. Okay, so for the y, okay, it will be 2 also. It will be 2. Okay, and for the C, it will be 4, of course. 4. Okay, so how to draw this thing? This is an ellipsoid, it's not a plane. Okay, so when this is 2, here will be -2. Okay, the other side will be -2, right? -2. Okay, so you have to draw it. Okay, just roughly sketch it. Okay, and then you will have this shape, -4. Okay, so you have to sketch like this. Ellipsoid, right? So the ellipsoid. Okay, so you have this one. Okay, so this one is the 3D drawing. Okay, the question also asks you to choose a suitable projection, right? Okay, so if you view this ellipsoid, okay, from the top XY projections, okay, so you will see a circle. Okay, so we just draw a circle. 2, -2. Okay, so this one will be your XY projections. Okay, so this is the XY projections. Okay, extra projections. Okay, next is to find the volumes. Okay, is to find the volume. Okay, using cylindrical. Okay, number 2 is to find the volume using cylindrical coordinate system. Okay, cylindrical coordinate systems. So we look at the volume, so it will be triple integral. So if we use the cylindrical coordinate system, it will be dz, r, dr, and d theta. Okay, here will be 1, right? So we need to know what will be the range for the dr. Okay, range for the dr. Sorry, for the dz. For the dz. Okay, so let us look at this one, the volumes. Okay, so imagine you are sitting inside. You are inside this ellipsoid. Okay, so when you refer down and up, you will see the ellipsoids, right? You will see the ellipsoids. Okay, so it will be, okay, so the equation, let me write down one more time. It is 4x squared plus 4y squared plus z equals to 16. Equals to 16. Okay, so the z will be equals to 16 minus 4. Okay, this one I group it because later on I want to change to cylindrical. Okay, it will be easy. Okay, so this is the upper part, and you also have the negative part, right? Wait, let me check. By changing to the volume ellipsoid, they didn't talk about whether it's the upper or lower, so you should have this 16 minus 4 x squared. This is a square, right? Plus y squared. Okay, so both you can change it to the cylindrical coordinate. So the volume will be z. Okay, z will be this one. Okay, the dz will be from negative part, okay, to the positive part. So let me write down the dz interval. The dz interval will be from the negative. Okay, so I convert it directly. 16 minus 4r squared. Okay, to 16 minus 4r squared. Okay, next is the r. Okay, so r have to refer to projections. So the r has a radius of 2. It's a 2. Okay, 2. Okay, so the dr will be from 0 to 2, and the d theta will be a 0 to 2 pi because it is a complete circle. Okay, it's a complete circle, right? So volume will be equals to 0 to pi, 0 to 2, 0 from negative, 16 minus 4r squared to 16 minus 4r squared. Okay, here will be dz, r, dr, and d theta. Okay, so this is 1. This is 1. So let's do it. 0 to pi, 0 to. So it will be 16 minus 4r squared minus negative. So it can become positive. Okay, 16 minus 4r squared. R, dr, and d theta. So this one will give you 2. Okay, so you can take out the 2 over here. I will take out the 2. 2 pi. Okay, 0, 2. Because this one will give you 2, 16 minus 4r squared. So I take out the 2. And I want to press calculator for this. So let's press calculator. Square root 16 minus x squared and x. Okay, you get 7.48. Okay, d theta. Okay, and then multiply 2 pi and 2. You get 93.96. So this is a volume. So this is a unit cube. Okay, so this is the answer, the volume of the ellipsoid. Okay. Unicode. Am I correct? Let me check again. Let me double confirm again. 60 minus 4x squared minus 4x squared and x, 2 and 0. I think something wrong with my previous answer. X squared 4x squared x. So I get 5.33. Is it correct? 2 pi. Yeah. 67.02. Okay, 67. Okay, so this is the volume of the ellipsoid. Okay, thank you.